Hello world and welcome back, and today we're right back onto the Minicomputer trying to figure out what is going on with the FFC card. And over the past 2 weeks I've been working really closely with two members of the Discord. First, Meisaka has created a reverse engineered schematic of the entire FFC card, and it has been quintessential to every inch of progress we have made in trying to figure out what's going on. It is just amazing. And I've also been working very closely with SJ Software, or Gecko. We have been digging through the microcode. Well, I say we, he's been digging through the microcode. A lot of that is well over my head. But he's been digging through the microcode and talking with me, and we've been testing things and trying to figure stuff out. But we've all kind of hit a roadblock where we're waiting on a riser card because we need to probe some things on the FFC card, and when it's installed in the back plane inside the card cage, it's just pretty much impossible to get to. So the riser card will plug in and essentially bring the backplane connector all the way out to the front of the machine. Then we'll plug the FFC card into that, and that'll give us a lot of access to probe and test things while the machine is operating. But that's not here today, and it doesn't actually matter because what I want to do today, interestingly, has to deal with the Hawk drive. In our testing of the FFC card, we discovered some really cool stuff on the Hawk drive that I think will help us out tremendously. But the Hawk drive is always a risk whenever we spin it up. It is not fragile, but there's not any spare parts for it. And well, we only have one operating system platter, and that makes me super nervous. So today we're going to take a look at where we left off with the FFC, the interesting things that we discovered, and then we're going to try and solve the problem of only having one operating system platter, so I don't feel quite as nervous using the Hawk drive to diagnose the FFC and the floppy drives, well, and ultimately the Finch drive. So let's hop over there and get started. All right, here's where we left off last time. I've got the diag card in the machine. I've got the auxiliary tests pulled up, and the FFC card is plugged into drive A here, which is currently on through my homemade PCB adapter boards. And if I do 08, which is the floppy seek test, and I hit enter, it loads the head and it does the full-on seek test. So if I hit Control C here, that will log the command in the multiplexer buffer. When the head comes all the way back and hits track 00, it'll then check the multiplexer for that Control C command, and it'll finish the seek test. So if I hit space, the next test is 09, which is a floppy read test. And if I hit enter on it, I can hear it loads the head, but then nothing happens. It says busy, did not clear. If I press space, come back to the main menu here, the head is still loaded, and if I try to run either the seek test or the read test again, so we'll just do 08, hit enter, well, it doesn't do anything. It just sits here completely dead, and then it says FIN did not go off. The only way to get it out of this is to reset, and when I reset, it unloads the head, and now I can go back and hit 08, and our seek test is working perfectly again. Now this is a relatively limited test. FIN did not go off, or just busy did not clear. It doesn't give us a whole lot of information. And so it would be really nice if we had something that was a little more in-depth. Maybe we can do a write test, or we can format the floppy or something like that, but we can't do any of that from here. The diag card is just extremely limited because the tests have to fit on small ROMs. But it just so happens that we have a huge hard drive here, and you can actually stuff a lot more testing onto this. So I'm gonna spin it up. Now, in order to do that, I need to actually turn the computer off here. I've got to pop the diag card out, and then I've got to turn off the sense switch on the front of the CPU. We'll turn the computer back on, and then we'll push start and stop here on the Hawk drive, and it's going to start spinning up. I heard it spin up. The noise reduction on my recorder here is probably going to cut some of that drone out, but it is very loud, particularly because I have the lower panel of the machine off. But since we have the contents of the removable platter, which has our OS, stored on my hard drive on the computer, I can dig through the files and find what looks like interesting things. So I want to show that to you guys. So I'm going to bring the camera in nice and tight on the screen here, and let's take a look at some of the interesting things that we found on the Hawk drive. So I need to actually reset the system, and I want to do that using the select button. That'll get us back to the D equals prompt. I'll type H0. This should load the Whipple and get us to the name equals prompt. If I type @OS in here, it just loads the operating system. But if I type $?flex, hit enter, it's going to ask me what disk. That's the removable platter, so 0. Hit enter again, code equals, there is no code, so we just hit enter here, and there we go. Flexible Disk Diagnostic Revision 1.3. And this has a ton of different things that we can use to more fully diagnose the floppy drive, because we have format, seek, read, write, and memory test. And then there's a bunch of other stuff that I'm not actually entirely sure what it does. So if we do the seek test, press S here, that's going to say enter our unit number, and it says 0 to 3. Now the FFC card can support up to 4 units. Unit 0 has to be the floppy, and the last unit has to be a Finch. Now the combination of how that arranges in the middle, not really sure. I was thinking you could do floppy floppy Finch, or floppy 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 Finch, or something like that. But we've been looking at the FFC card and some of the microcode, and it might only support 1 floppy. Everything else has to be a Finch drive. That's still kind of up in the air, but it doesn't matter because that's a problem for the future. Right now, we're only worried about 1 single floppy, and that is unit number 0. So we'll go ahead and enter unit number 0. Then it says enter seek pattern. AUDCMR. I don't really know what any of these mean, so we'll just pick one at random. We'll go with U. And then it says enter low track in hex. So we'll go 0, 0 to start at track 0. Then enter high track. And I'm not sure how many tracks are on 1 floppy disk. Maybe in the realm of 70. But I'm not smart enough to do that conversion into hex. So I'm just going to pick a relatively low hex number, like say 2F. So we'll go ahead and hit enter. It says enter printer. I believe this is where it's going to show our error log. And that should be on CRT 0, which I think is going to be unit or device 0. So we'll just hit 0 for this, hit enter, and yeah, it's seeking the floppy. I can see it pushing the floppy all the way out. And oh, I think we went too far because it's completely just ramming up against the edge. We've got to stop that. So we'll go ahead and hit Control C. That says press space to continue. Maybe there's less than 2F tracks. I don't know. Either way, things aren't working right with the floppy disk, but we have the tools here to actually do the proper diagnosis. We just need to figure out what's going on with the FFC card and why things are misbehaving in such strange ways. But I want to be able to use this without fear of damaging our only copy of the operating system on an actual platter. But right now it's spun up and it's working, which means we could use the built-in Centurion tools to copy the removable platter to the fixed platter, and then we'll have it in 2 places. And in order to do that, we need to get back into the operating system. So I'm going to push the load OPSYS button. That's going to get us back to the D equals prompt, and then we need to do something that I've been far too scared to do up to this point. And that is we need to turn the physical write protect switch off for the fixed platter. And the front of the Hawk drive has it marked. Right down here it says write protect and then cart and fixed. So we'll just go ahead and turn it off for the fixed platter. Even though we're not doing anything, that still felt scary. And then we'll do H0. That should boot us right back up into the operating system. We'll hit enter, 02, 23, 88, The time is whatever, 1200. We'll hit enter, and when it says CRT 0, we can do probably the most terrifying thing I've done yet. So we'll do .sta, take a look at our drives one more time. Soft term is 0, programs is 1. We want to copy soft term onto programs, and the utility to do that, and well, all of the operating system utilities are saved in a folder called S. So if I hit .dir space S dot space 0, hit enter, this was where we had our text editor compose. But if we go just a couple of spaces up from compose, we have dump. This is the one that copies one platter to another. So here goes nothing. We'll get to the end of our directory listing here, and then I'll do s.dump, hit enter. Okay, so it's going to show us what our drives are, and it's asking me to enter the source disk. Our source disk is soft term 0. So we'll hit enter on that. Our target disk is 1. So we'll go ahead and hit 1 on that. It says, do you want to check volume dates? Now, Ken has told me that this keeps a log of whether the person checked the volume dates. And if the volume date of the drive of the platter that's getting copied to is newer than the one that is doing the copying from, it's going to throw up an error. But we know it's newer, we can see the dates, so we don't really care about the volume dates at the moment. So we're going to say no to that. Do you want to check volume labels? If the labels don't match, it's also going to throw up a little bit of an error, but we know they don't match. We're doing our due diligence here. So again, we're going to hit no, hit enter. It says enter print device for copy error log. We want that to be CRT0. We'll hit enter, and it's going to ask me if I'm ready. And this is the scariest thing that I have done yet, because now we are erasing data and obviously duplicating data. It's absolutely horrifying. But I guess we'll just go ahead and hit Y and see what happens. So let's hit Y, hit enter. And okay, there it goes. Yeah, all right. Lots of stuff is happening. Oh, WP1. That should not have happened. All right, so we've got another failure. This is one of those things where like the goal is here and we keep taking tangents to get to the goal. But essentially I tried to do the dump program to copy the removable platter to the fixed platter, and I have the write protect switch off, but when I tried to copy it, it told me that the write protect switch was on. So we've got some troubleshooting to do to figure out what's going on with that. And I did some digging through the manual, and there's actually a surprising amount of logic stuffed behind those switches. So I think we're going to need to take the Hawk drive apart at least some. This is just going to end up being a really long day, huh? But there's nothing for it except let's just get to work. All right, I think I've got it. The control panel on the front has a ribbon cable that runs all the way down, around, and then into the bottom of the card cage at the very back of the drive. And that ribbon cable wasn't plugged fully in. I went through a huge amount of different troubleshooting to get to that spot. I replaced the control panel on the front. That didn't change anything. I replaced the control card in the card cage. That didn't change anything. And these were the things that the manual told me to do. I followed the manual flowchart. But Ken Romaine told me to check that cable, and I looked for pinches and kinks and didn't see any, but turns out it was just not pushed fully into the card cage. And now I think it's working correctly, and we can actually check it without spinning the drive up on TOS using the diag board. So I've got TOS booted up here, and if I do MF140, this will tell me what unit is selected. So F0 is going to be the removable platter. That's the one that was working before. So if I check MF144, it's going to say 0080, and that is with the write protect switch on. So if I turn the write protect switch off and check it again, MF144, it's going to be 0000. All right, so we know that 80 is write protect on, 00 is write protect off. MF140, and now we're going to change over to the fixed platter. So we'll say F1, change that over to the fixed platter, and then we'll do MF144, and it's 0080. So the write protect switch is currently on. I will turn the write protect switch off, and we want to see 0000 here. So MF144, 0000. It's working correctly now. So the next step is to pull the diag card out, restart the computer, load it up into the operating system, and we'll try our dump program again. So we had the Hawk drive completely apart. We've got it back together. It seems to be working correctly now. Let's do the dump program. S.dump. It's gonna do all of its loading thing. Our source disk is going to be soft term, which is 0. Our target disk is going to be programs, which is 1. Do you want to check volume dates? No. Do you want to check volume labels? No. The print device is CRT 0. Let's go ahead and hit yes, and here goes nothing. Oh, that is a very interesting, it's copying stuff over. We can see it copied over the folder @sys, then @load, it copied over the folder S. It's going through and copying the folders over. Oh man, all right, so we are actually reading from the removable platter and writing to the fixed platter. There's no turning back now. Whew. Okay, so it looks like it got the folders in, and now it's going through and doing the individual files that are on there, RV, OIA. Boy, it's going real quick. I guess these files. No errors. Do you want to guard the target disk? This is like a software write protect. We're not going to do that. Do you want to no guard the source disk? No. I think that's it. Let's do a .sta here. We have 2 soft term labels. We did it! Oh my gosh. All right, .dir1. The fixed platter is showing exactly what the removable platter was. So let's try booting off of the fixed platter. All right, I just pulled out our operating system removable pack. Now the only operating system on the machine is in our fixed disk. I put in a different removable pack. It's just pure data. There's a whole lot of really uninteresting personal information on it. The heads just loaded. I was killing time until the heads loaded. So let's see if we can get into the operating system. H1. All right, it looks like we're getting into the operating system. All right, it says previous system date is 7/26/89. That's the system date of the fixed platter. That's what it was. But you know what? Let's just make a new system date. So the month right now is 09. Today is 2/8. And then the year is 22. That's our new system date. And the time is whatever, it doesn't really matter. 12 o'clock noon. It's really not actually noon. Oh, that is an interesting new error. I got an abort error out of that. It's a new day. I got a little bit of sleep last night. Not a whole lot. I spent a lot of time trying to figure out just what was going on. We were getting a really weird error. As a matter of fact, I'll go ahead and show you. So we'll hit the load opsys button to reset it. The RF switch on the front needs to be pressed in because we want to boot off of the fixed platter. I'll type H1. Now the only operating system that we have is on the fixed platter. The removable platter is something completely different. And then I would, as always, just hit enter. It says enter previous system date, and it's got a random date in here. So we'll just pick the same date, 01/01/97. Then we'll hit enter. It says enter system time, doesn't matter. Hit enter, and there we go. Abort 33, some wild error. I just was racking my brain over this and I couldn't quite figure it out. So let me restart it one more time because I think I've got it cracked. So I'll hit the load opsys button again. We'll type H1. If we look right here, it says max disk equal 1, system disk equal 0. This is something that I totally forgot about, but once upon a time, it wasn't exactly plug and play. You had to pretty much hard code everything, and the operating system is hard coded to have the system disk be 0 because that's the platter that we copied it off of. 0 is the removable platter. Now I can adjust it here. I can do S equals 1, hit enter, and now it says system disk equals 1. And so if I hit enter from here, again it has a random date, so we'll just do that same date again, 08/23/84. I'll hit enter, the time doesn't matter. And if we hit enter from there, well, we don't immediately crash out. It's starting to load into the operating system proper. Now we've got CRT0 ready. If I type STA, hit enter, there we go. We have now successfully booted off of the fixed platter. We're not out of the woods yet because I have to type S equals 1 every time I boot. And there's a couple other problems as well. For example, if I want to run the composition text program that we had, compose, normally I would type s.compose, hit enter, and it would just load it. But now it says file not found. And that's because it's looking for that file on platter 0. So instead I have to tell it where the default disk is. And I can do that with a .setadd equals 1. If I hit enter there, and now I can do s.compose, hit enter, and there we go. Now we're into our text composition system. All right, so let's try to fix one of these problems. So I'll exit out of this with just Control-C. And so now we're back at the prompt and we can do something else. And what I want to do next is I want to try and edit the operating system configuration file to set it so that the default disk is 1, or the system disk is 1 at the very least. And there is a utility that is specifically for this. It's called sysgen. I only really know about this utility because it was in the manual that Jeff provided me with. It has been a treasure trove of information. So if I do p.sysgen, that should load it up. Okay, so it says enter configuration library name. We don't have it in a folder, so we just hit enter there. The configuration file name is @osn, so we'll hit enter on that. The disk number of the configuration file is disk 1. We'll hit enter there. Now it's going to load up the sysgen utility. And you can see right here, we have a couple of available options. And so let's just start with number 1, system constants. And now we're seeing some really cool stuff. First things first, in the top left here, it says system disk and has 0 there. So I can change that to 1, 0, 1. But I can also change a couple other things like timeout value, power line frequency, and multiple processors. That sounds really cool. I've asked Ken about that. He's not too sure what that means, but I like the sound of multiple processors. Below that, we have some information about how the system is set up. You can see it says disks 8. That's pretty wild, but we'll take a look at that here in a second. The first thing that I want to do is get out of this screen. I want to save what I've got and go back to the main menu. And so intuitively, you would just hit enter. And that doesn't do anything. That just takes you back up to the top. So if we look at the manual, it says press F4, which is great, except I don't have an F4 key. This is an ADS Regent 100 and they didn't come with function keys. And so I was ripping my hair out about this yesterday, pretty late into the night. And I woke up this morning and Gecko is an absolute rock star. He did some digging through the ADS Regent 200 manual, which is really similar, and figured out the key code to essentially emulate an F4 key. So I need to hit Control B and then the number 4 and then new line. And yeah, There we go. We exited back out to the main menu. So let's just test this right quick. We'll do end of program. I will hit the load opsys button to reset us back to D equals. Type in H1. All right, so now it says max disk equal 1, system disk equal 1. How cool is that? So I shouldn't actually have to type S equals 1. I can just hit enter, 082384, hit enter, set our time to 1200, hit enter, and it's loading straight into the operating system. We have fixed that problem. All right, so there's one more thing that I really want to do in the sysgen. So we'll boot back into it, p.sysgen here. And the next one that I really want to look at is disk drives, option number 4. So if we hit that, well, it said that we had 8 disk drives, and that actually makes sense if we look at this, because it doesn't count the drive as 1, it counts the platter as 1. So Hawk is disk 0 and disk 1, because it's 2 platters. We also had the Phoenix drive as part of this system when I got it, and this is the operating system from the genuine system. So you can see it's got the CMD Phoenix drive. Now this is incredibly important because no matter how much work we do on the FFC card, the Finch, or the Floppy, the operating system will never see it unless I modify the operating system configuration file to have the Finch and Floppy in there. So I'll just go ahead and punch in D13. Oh, I held shift and that caused some issues. We'll just try to type over it and yeah, there it goes. Okay, D13 Floppy, single-sided NC, which I imagine stands for new controller. Also, let's go ahead and add the Finch. That's gonna be D11. So I'll hit enter on that and there we go. Finch. So Floppy and Finch are now in our operating system configuration file. So we need to exit out of here, and that's going to be Control B for new line. And then we'll do end of program. And do you want to see a listing of the configuration file? Sure, let's go ahead and take a look at that, see what it looks like. And our print device name is going to be CRT0. And I don't know what I'm supposed to glean from this. It's all going by rather fast. But everything seems to be working perfectly. This was such a huge milestone to get the OS onto the fixed platter so we can put our removable platter OS someplace safe so it's no longer in danger. That was incredibly important, but I'm so happy and a little tired. I'm gonna just go take a nap for a while, but I want to thank you guys so much for watching. This has just been a really wild deep dive into what computing was like once upon a time, and I hope you guys are enjoying this journey as much as I am. So thank you so much, and I hope to see you in the next episode.